Next, let's plot the ROC curve, calculate the AUC metric. To do that, we can start by calling the ROC curve display from estimator. We'll set our pre-trained model. Let's stand for the logistic regression model. Put our test dataset and the Y test set. Let's now call the plot.show function to show us the So you will get a plot showing the ROC curve for our logistic regression tuned model along with the ROC score. So this is how it looks. So the AUC score is equal to around 92. And this curve, as you could see it, this shows the false positive rate on the x-axis, okay, and the true positives on the y-axis. The rate of the false positive, or let's say the false positive on the false positive on the x-axis, and the true positive rate on the y-axis, which it's here. So as you could see that it's a simple function that it already exists in the Scikit-Learn. So, you know, again, to recap on the function that we've used, we used our main logistic regression tuned model and the X-test dataset, which include the feature matrix on the test set, and the Y-test, which include the, if you recall, the true labels, the predictions that we're looking for. So here it contains the feature with its values, and here it contains the dependent variables or the true labels of the test dataset. To more simplify it and go again through the plot here. So as we said, so the plot will show the true positives. We call it the TPR on the y-axis. Okay, these are the true positives was predicted. Here on the y-axis, and the false positive in the x-axis here. So additionally, the AUC score will be included in the legend, as you could see here, automatically reflecting how well the model distinguish between the two classes. To interpret this, you know, results, so the ROC curve receiver operating characteristic curve, it shows the, as we mentioned many times, the relationship between the true positive rate, the TPR, and the false positive, the FPR. The true positive, it's also, we call it as the recall, and it represent this one. This represent the recall the proportion of the actual positives, okay, cases correctly identified by the model. And the false positive here, it represents the proportion of the actual negative cases that were incorrectly classified as positive. A key insights that we can take from this curve, it's the closer of the ROC curve is to the top left, okay, where TPR is high and the FPR, the false positive, are low, the better the model is doing, like distinguishing between the two different classes. And if the ROC curve is along from bottom to left, the right from here, it suggests that the model performs no better than the random guessing, okay? Now let's talk about the AUC score. The AUC score is a single metric that summarizes the overall ability of the model to distinguish between the two classes. In our case, we have around 92% or 0.92 means that the model has 92% chance of correctly distinguishing between the randomly chosen positive instances and randomly chosen negative instances. So there are some like an existing scales that, you know, it could tell you if your AUC is doing well or no. So if it's less than 0.5, so the model is performing no better than the random guessing, as we said, like flipping a coin, okay? 50% you might guess it, 50% you might not guess it. If it's between like let's say 7 to 8, the model has fair discrimination capability. But if the score in our case is more than 90%, so the model has an excellent discrimination ability to distinguish between the true positive, okay, and the false positives.